All right, here are your notes for section 2.3 in algebra. My hair looks like it's totally messy. It's not really, I mean, it's braided. It's got a little, so I did fix it, but it's kind of sticking up all over. If I get too close, you probably see the grays in there. Anyway, solve two-step equations. Your goal is to get the variable alone. Same as the rule that we had on section 2.2. It said solving equations, one rule, get the variable by itself. It still is the only rule, but this time it's going to take more than one step. Step number one, undo any addition or subtraction. If you have addition or subtraction of terms in the equation, you got to get rid of those first. Then you undo any multiplication or division after that. It's like our order of operations. We've talked about PEMDAS. I know I've also drilled the idea that I don't like the spelling of PEMDAS because it's not true when you talk about multiplication, addition, and subtraction. But now we're going to, because we're solving and we're breaking apart an algebraic equation, we already know the answer of an algebraic equation. We just are trying to find the x in the middle of it. Now you get rid of addition and subtraction first. That's step one. Then do multiplication and division. So because we're trying to find a piece of the problem, we have to do everything backwards. Here's an example problem. Let me get this out of the way a little bit. Go ahead and write that down. 5x plus 9 equals 24. Undo any addition or subtraction first. We know that when we have a plus 9, when we're balancing an equation, we must minus 9 because a positive 9 and a negative 9 equals 0, which means it's gone. But here it is again. Whatever you do to one side of the equation, you must also do to the other side of the equation. So you're left on this side with 5x equals, and again, if you want to put your line all the way through it, you are more than welcome to continue to do that. I'm just not going to on my end. 24 minus 9, which is 15. In one-step solving, you would be done, but as you can see, this variable is not alone yet. It's not isolated. We still have a 5 there. So now we have to undo any multiplication or division. Since this is multiplication, to reverse it and do the opposite of multiplication, you are now going to have to divide. And I know I always show division by just the division bar. If you prefer to write divide by 5 instead of the division bar, I'm still okay with that as well. Whatever you do to one side of the equation, you must do to the other side of the equation. When you divide these 5's out, they equal a 1 instead of a 0. Makes sense. This is 5x plus 0. This is a 1x. The 1 is invisible. You would never, ever, 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 ever write it now that you're all grown up and in high school. Okay, we don't put 1's in front of x's because we know that there's 1x there. We don't have to tell people that there's 1x. 15 divided by 5 is then x equals 3. And let me just send out a super friendly reminder, but very important reminder. 3 is not your answer. 3 will get marked wrong. X equals 3 is the answer. X equals 3 is what we're looking for. All equations start, carry on, continue, and end as an equation. So keep it that way. Next problem. Fractions. Okay, it's not a fraction, it's a division bar. If you are still scared of those, or you prefer not to use them, x divided by 4 minus 3 equals 2 is okay. It's just a much more common to see them written this way, so I want you to get used to seeing them written this way. We still have to follow the rules. It says undo any adding and subtracting first. So to get rid of subtraction, we are going to add because negative 3 plus 3 is 0. And by turning that into a 0, the only thing you have left on this side of the equation is x divided by 4. But whatever you did to this side of the equation, you must also do on this side of the equation. So since we added 3 to both sides, we are now going to take 2 plus 3, which is 5. And at this point, to help yourself along, you could ask yourself this question. Self, what number could I come up with that if I divided it by 4, we could come up with 5? We all want 5 pieces of pizza, and there's 4 of us in the room. How many pieces am I going to have to cut that pizza into? Probably 20. 20 divided by 4 is 5. That's the logical reasoning. How did we get to that? We undo division. We get rid of division. Getting rid of division is multiplication. 4 times x over 4 allows you to cross cancel those x's or those 4's and leave behind your x, which is your ultimate goal, is to isolate the variable. Here it comes again. You're going to get sick of this. What you do to one side of the equation, you have to do to the other side. Don't forget to multiply by 4 over here, which would give you 5 times 4, or 20. X equals 20. Again, if you did the same over here, it would first be an add 3. You'd be left with x divided by 4 equals 5, and the opposite of multiplication or division is multiplication. You still would get x equals 20. It would just look a little bit different. If you want to know if you did this right, other than looking in the back of the book and double checking it, you could plug in the 20 and take 20 divided by 4 minus 3. On a calculator preferably, because a calculator won't make mental errors. 20 divided by 4 minus 3, and it will tell you that the answer is 2. Let's do another two-step one with multiplication in it. 4y minus 4 equals 16. You know what? Try this one yourself. Pause it, try it, and then come back. Pause. And you're back. Did you add 4 to both sides first, so that you had 4y equals 20? Did you then divide by 4, either with a fraction bar or a division sign? And did you finish with y equals 5? And did you check your answer? 4 times 5 minus 4 equals, calculator says, 16. Bingo. And every time you get one right, you can be like, oh, I know what I'm doing. I feel good about this. I like algebra. I'm getting a little bit more confident each time. Maybe it just helps you as we do each one. Until I throw this at you. It's okay. I turn the x into a y and then the y into a z. It doesn't matter what your variable is. Be careful that your z doesn't look like a 2. A lot of times I make my z's with a slash through them because my 2's look like this, and so would my z's unless I put a slash in them. So whatever you have to do to make it look like a z, don't change it into a different variable, please, because you're going to need those different variables when you apply your algebra to real-life problems, formulas, chemistry, physics, biology. They all have different formulas with different variables, so get used to them. This is a subtraction problem. However, addition is not your first step because you are trying to isolate this variable, which means leave the z over here, move everything else over there. Well, by everything else, I'm saying move that 7. Move that 7 over to that side of the equation. Try to cover this up. If you're only looking at that 7, it's a positive 7. How do you get rid of a positive 7? By turning it into a negative 7 or subtracting 7. Whatever you do to this side of the equation, you must also do to this side of the equation. 10 minus 7 is 3, and 3 equals a negative z. Or we've already referred to this as the opposite of z. If the opposite of z is 3, then z itself must be negative 3. If the opposite of z is 3, then z must be negative 3. If you're not sure of that or you don't care for that, then go ahead and divide it by negative 1 because there's an invisible 1 right here. Negative 1z divided by negative 1. If you divide by negative 1 over here, it's negative 3. I personally prefer the logic of if the opposite of z is 3, then obviously z is negative 3. Careful, I'm going to point out a common mistake. Somebody writes this in their notebook. This is what their handwriting looks like. Okay? Then they subtract 7 from both sides. Cross off the 7. I know, it's small. That's what half of them look like in your notebook. And they go 10 minus 7 is 3. Drop down the equal sign and drop down the z. Because they wrote so small, or so messy, or so tiny, or big X's, they lost the negative. Please exaggerate that negative so it doesn't get lost, no matter how big you write. If you write small, still make a big negative sign. Okay, that's a little bit obnoxious, but it's going to prevent you from making a mistake and accidentally crossing off that negative. Save you some points. Just a hint. These are two-step equations also, but they look a little bit different. Go ahead and write this down. Well, write the instructions also. Solve by combining like terms. It's 7x minus 4x equals 21. Okay, notice that there's two x's. But lucky for us, they're on the same side of the equation, which is what we want. We want our x's to be on the same side of the equation, and we just want them to be together. Like terms mean that they have the exactly same variable. Like terms have the exact same variable. So when we take 7x and we subtract 4x from it, we could go old school. 7 x's. We take away 4 x's from them. What are we left with? 3 x's. Wait. We've just been doing all this with addition property, subtraction property. Why didn't I say plus 4x, plus 4x? Cross that out and you got 11x equals 21. I just showed you that over and over and over in last section, in this section, and now I didn't do it. Why didn't I do it? I can't hear you. Speak up. Why didn't I do that? Who knows why I didn't do that? You do? Just kidding. I can't hear you. Why didn't I do that? Because I didn't put it on the other side of the equal sign. You only do the opposite of what you're looking for when you're trying to balance out the other side of the equal sign. When you're trying to move something across those tracks and get them onto the other side. We didn't move anything. We just said, what happens when you take 7 x's and minus 4 x's? This is why we practice solving or simplifying expressions, because this is just an expression when it's all on the same side. 3x equals 21. What do you do in the next step? You divide by 3. 3 divided by 3 on this side isolates your x. 21 divided by 3 on this side gives you a 7. And again, not just 7, but x equals 7. This one's a little bit different in checking your answer, though, because now you have to check your answer using two different x's. You have to plug in the 7 both times. So if you're looking at that on a calculator, what you should see is 7 times 3 subtract 4 times 7. You got to put that 7 in there. Oh, 7 times 3. Where in the world did I get that? Start over. 7 times 7 subtract 4 times 7 equals 21. So it's a little bit different in checking your answer, but you still can. Let's do a couple more. Go ahead and try this one on your own. Pause it. Come back. Pause. That's my symbol for pause. And you're back. If you have 5 b's and you take away 7 b's, that's not good. I don't know how you have negative 2 b's, but you went too low on the number line. Negative 2 b's equals 4. You just combine these together. 5 minus 7 is negative 2. Divide that. Don't lose your negative. By negative 2. You should be able to do this in one step. Divide by negative 2. And you're left with just a positive b, which is what you want. But whatever you did to this side of the equation, you have to do to the other side. I hope you said that. 4 divided by negative 2 is negative 2. Check your answer. Type in 5 times negative 2, subtract 7 times negative 2 equals, and you get 4. Think you get the point? This one would be 6w equals 24, which would then become w equals 4. This one is on the other side, if you want to follow along on this one. Be very careful. Go ahead and write it down. Negative 16 equals 5d minus 9d, which means you have a negative 4d. When you have a negative, go ahead and divide by a negative right away. It cancels both of them out in one step. You don't have to divide by 4 and then divide by a negative. Divide by negative 4 over here. What is a negative divided by a negative? A positive. What happens over here? You have just the d, and it's okay that it's on the other side of the equation. Leave it that way. this is part 2. Part 2, go ahead and take the time to write this down. All right, hopefully you finished this, wrote it down. The output of a function is 3 more than 5 times the input. Find the input when the output is 18. You know what this is? This is a combination of translating verbal phrases, which we did in chapter 1, input, output, and functions, which we also did in section 1.8, and now solving equations. So this is a great example of when you start learning algebra, it goes day to day. You can't forget something that you've already learned just because you already took the test on it. So part 1, we have to come up with an equation. And what we've been practicing over and over and every time we make rules and equations is that outputs are y and inputs are x's. So if we're going to continue with that trend, that way we can set it up. The output of a function is 3 more than 5 times the input. And some of this we already know how to translate. We're just now stuck in the words output and input. So let's start with the output, y, of a function, which is a prepositional phrase. And our English majors know that we don't need that prepositional phrase. The output is 3 more than 5 times the input. And we keep working on this, making sure you just put 5x, not 5 times x, not 5 dot x, not 5 parentheses x. It's just 5x. So all I did was read that with a couple of labels carefully. The output, y, is equals 3 more than, which is plus, 5 times the input, which is 5x. That's step 1. And we ended with the period, so you don't have to put the rest of it. Then it says, substitute, then solve. Substitute what, then solve? Well, let's read the next sentence. The next sentence says, find the input when the output is 18. Find the input. We know we're looking for x. We got to find x. When the output, y, we know that y is 18. It says substitute, then solve. So we take that 18 and we substitute it in for our y. 18 equals 3 plus 5x. They're not going to give you a word problem like this in the same section of what everything else we did if when you were done with the word problem it didn't look like we were just getting done with. We just solved a whole bunch of 2-step equations. So this word problem is going to be a 2-step equation. We know the answer, we just don't know the x. So once you get it set up, then you just solve it from there. Because 3 is positive, you must subtract it to cancel it out. Whatever you do from one side of the equation, you do the other side. Are you sick of me saying that yet? It's because after years of teaching, I know that some people only subtracted on one side. 15 equals 5x. It's 5 times x, which means we now need to divide by 5. And whatever you do to one side, you do to the other. Divide by 5, you can use the fraction bar or the division sign. 15 divided by 5 is 3. Now, as I've told you before, all equations start and end as an equation, but be careful. Did this start as an equation or did it start as a word problem? Did the question ask you, find x when the output is y or the output is 18? It did not say find x. This goes back to our 5-step problem solving, even though we didn't set up perfectly all 5 steps. Step 5 is a word label. Find the input. We made the input be an x. So down here, instead of saying x equals 3, you could either say the input is 3 or just input equals 3. But don't call it x. We invented the x. We didn't have to call it x. We could have called them y and z or a and b or l and k. So because there was no x in the original word problem, we will answer the word problem as is. Either the input is 3 or input equals 3. Let's try one more of them. Go ahead and pause it and write this down. Oh, give you my pause. Pause. And we're back. If you write down this problem, then we go through step 1 and step 2 again. The output of a function, prepositional phrase, is 4 less than 2 times the input. Input is going to be x. We've talked about this word less than before, that we have to start with our 2 times the input. If you don't start with an amount, how do we know what it's less than? So less than always comes after your original amount. There's your equation. Step 2 says substitute and solve. What are we substituting? Find the input, 1 the output, y is 6. Go ahead and put a 6 in, and again we have a 2-step solving equation. What do we do with that 2-step solving equation? Add 4 to both sides, get 10 equals 2x. Cross those off. I know I just did that way too fast. Slow it down, pause it, whatever you have to do. Watch me in slow motion. Kidding. Divide by 2 on both sides. And 10 divided by 2 is 5. 5 equals x. Go back and look at your question. Did it say what does x equal? Nope. It says what is the input? Input is 5. Could you check your answer? You bet you could. Go back up to the word problem. The output is 4 less than 2 times the input. Take 2 times 5 and you get 10. 4 less than that is 6. Bingo. Got it. We're done. You've probably been waiting for your assignment this whole time. So, notes are done. Go ahead and get started on your assignment while it's fresh in your mind. Do a few problems. If you get stuck, look at your notes. That's why you make the notes in the first place, is so that you have something to look back at. Good luck.